She works! Come, my pretties, come!
Hi everybody, so I get asked a question quite often, and that is, heat pumps, how do they work? And I like the word heat pump, because it's sort of, I don't know, it implies something more than there is to my mind. And of course the government here in the UK is very keen for people to be no longer using gas boilers, and there's an awful lot of incentives to go into air-sourced heat pumps to replace gas boilers. So heat pumps have become a thing of our century. The thing about heat pumps is, you find them everywhere. Air source heat pumps, ground source heat pumps, refrigerators and air conditioning are all the same thing, and they rely on some basic behaviour of gases. So the first thing we need to do really is have a quick review of how gases behave.
Gas molecules are always in motion, banging into each other and their surroundings. Temperature, like you'd measure with any ordinary thermometer, is a measure of their average kinetic energy, or basically their speed. Hot ones move quickly, cold ones move slowly. Volume is how much space something takes up. Pressure can be thought of as how often gas molecules collide with the walls of their container. These three values, which describe a gas, share a relationship. This relationship is described by the ideal gas laws. If you put gas in a container which can't change volume, increasing its temperature increases its pressure. One way to think about it is that the faster molecules more often collide with the walls of the container. The opposite is true as well. Decreasing the temperature decreases the pressure. These relationships still hold even if you change pressure first. Changing the pressure on a gas changes temperature. Now, heat is very different to temperature. Let's say you've got two blocks next to each other, one that's hot and one that's cold. Hot and cold, by the way, are just descriptions of temperature. Heat is the energy. It travels from the hot block to the cold block until they equalise in temperature, at which point there's no more heat travelling between the two. Equally, for a liquid to evaporate into a gas, it needs to absorb heat, and when it condenses back into a liquid, it
If you
gives off
remember
heat.
your states of matter, you've got gas, liquid, solid and plasma. The thing about gases is they're about the only thing that you can compress, and that's because they're very far apart. In liquids and solids, they're very, very close together and they're relatively incompressible, but gases are just hugely spread out, and so you can squeeze them together. I mean, in this room right now is about 1 kilo of oxygen, despite this enormous space that it's filling. So gases are unique in that they can be compressed, and of course that's key to their behaviour. So what do you need to make a heat pump? Well, turns out actually not much at all. You need three things: small tin, a big tin, and some gas, or a liquid that'll turn into a gas easily. All you do is connect the two tins and you cram your gas or your liquid into the small tin and turn the valve. Obviously the gas will then rush into the big tin and the volume has increased. And because the volume has increased, of course the pressure has dropped and the temperature has dropped, and you get a cold tin, a big cold tin. Now if you put that into a hot space, of course thermodynamics says the heat will go from the hot to the cold, and so the tin will warm up a little bit and the space will cool down, and that's exactly how a refrigerator and an air conditioner works. Now the next bit is a bit pushing the stone up the hill, because you've got to get that gas back out of the big tin into the small tin, and of course you've got to cram it in there because it's a small tin. You do that, you need a compressor. The compressor will cram the gas back into the tin, and of course because it's the same volume of gas and now it's now in a smaller tin, pressure goes up and hey presto, temperature goes up. You stick that in a cold space and of course that heat is going to then radiate out from there into the cold space and warm up the cold space. And that really is all there is to fridges, air conditioners, ground source heat pumps and air source heat pumps. That cold tin is stuck in the ground or stuck in the air and takes the heat from the ambient. It then gets put back into the house and gives the heat back out. So essentially you just get that hot tin and stick it where the sun doesn't shine and sure you're going to be warm and toasty. So any heat pump consists of 5 parts: a hot tin, a cold tin, some pipes to join the whole lot up, a compressor and your refrigeration liquid or gas. Once you put those things together, you have yourself a heat pump. Now, of course, in real world applications, they tend not to bother with the hot and cold tin. Instead, they use a coil, which is part of the pipes joining it up. And you find that coil in a fridge, buried in the fridge. And of course, the hot side is at the back of your fridge, which is why your fridge gets hot. In an air conditioner, that coil usually goes through some aluminium fins, which acts as a heat exchanger, and then you have a fan blowing the air over it. But the essential components of all of those devices are those 5 things. You can turn anything into anything else. So you can take an air conditioner and make it an air source heat pump if you want. You can take a fridge and do exactly the same thing. The only issue with fridges is that the compressor's made to run on and off. And so if you run it a long time, you'll wear your compressor out pretty quickly. So it's not a good idea to do it in the fridge because you burn out your compressor. But the theory is sound. You can certainly do it if you don't care about your compressor, because all of these things work in exactly the same way based on that simple idea of gas. When you change the volume, the pressure, or the temperature, they relate to each other, and that's all there is to it. Anyway, I thought I'd explain that because I've been asked several times. I hope you enjoyed the video. I hope it helped you with heat pumps and how they actually work. Thank you very much for watching. And please do remember to like and subscribe and click the notifications bell.